Hey everyone, on this lesson we are going to partition our dataset into two parts. The training partition, where we are going to train our model, and the test partition, where we are going to evaluate the final performance of the model. So this is a general method to measure the accuracy and the performance of a machine learning model. This method is called TrainTest because we split the dataset into two subsets, a training subset and a testing subset. And as we've said, we train the model using the training set and we test the model using the test partition. So now let's add here a new text window section. Let's name this to be partition of the dataset. And now we are going to partition the dataset into the training partition and the test partition, right? Now, in classification problems, we can usually use the stratified partition. This basically means that there will be approximately the same proportion of examples of each class in each partition. This is more important if we have classes proportionally with few examples. So now let's do this partition, this division of the dataset into two parts, the training part and the test part. Now here we'll need to use a method from the scikit-learn library. So we will need to import here from the scikit-learn library a new model. So we access now from scikit-learn. Now we access the model selection. And the method that we need to import here is the method TrainTest Split. With this method, we can make this partition of our dataset. So let's run this notebook. Let's run this window of this notebook. So now the notebook is up to date. We come here below. And now we apply this method that we have just imported. We just type train test split. Okay. Now here the first argument of this method is the data, that is all the features that we use to make this prediction. Basically, here the variable is the variable x, if you remember. Okay, this variable x here, that we have all of the data, all of the columns that we use for the prediction. So here we just type here the first argument to be the x, and then the second argument is the target variable, basically the real values of the answer variable, okay, of this response variable, where we have a 0 or a 1, depending if we have a malignant or a benign diagnosis respectively. So here this target variable is the y, so we just type here y. Now here the third argument is the test size, basically how is going to be the size of the test. And this normally, if this is a float number, it shall be a value between 0 and 1, and this represents the proportion of the data set that we're going to include in the test split. So we are going to choose here a 33%. That means if we have 100 samples on our data set, imagine, then on the test we will have 33 samples, and on the training the rest of them. So 100 minus 33 is 67. So we'll have 67 samples, right? So this is the proportion. Keep in mind, in our case, we have, if we see the shape, we have a total number of instances. The total number of samples is 569. So it is going to be 33% of this value in here. So after specifying the test size, we have here a variable that is called the random state. This random state in here is used to set the seed for the random number generator, so that with this we can ensure that the results that we get can be reproduced basically at different executions that we have here. If we run this cell and this window several times, we'll have the same results, the same configuration of the test partition and the training partition, right? Keep in mind that because of the nature of splitting the data in train and test is randomized, we will get different data assigned to the train and test if we don't set the random state. So we are going to choose here a seed, for instance, of 42. And now, since we are dealing with the problem of classification, we are going to solve a problem of classification, we are always going to use stratified partition. So here we have a Boolean argument which is the Stratify. And also this argument can take a value of the response variable. So here we just type Stratify equal to y. So the Stratify argument makes a split so that the proportion of values in the sample produced will be the same as the proportion of values provided to this argument Stratify. For example, when we set this to be Stratify equal to y, okay, if y is a binary categorical variable with values 0 and 1, which is precisely what this variable y is, okay, it can take two variables, values 0 or 1, and there are, for instance, 25% of zeros and 75% of ones, then if we set the Stratify equal to y, this will make sure that our random split has also 25% of zeros and 75% of ones. So this ensures that the proportion of the split and the proportion of values in the sample produced will be the same as the proportion of values provided to this argument of the Stratify, in our case, this target variable y. Again, this last argument is not mandatory, this is optional, okay, you can do the same problem without the stratified partition, however, this is recommended when working in classification and using machine learning models of classification. Very well. Now, what this method is going to return? Right? What is going to return this method? Well, essentially this method here, TrainTest Split, will divide our dataset and we will return 4 variables. The first one, the training partition of the data. So we have xtrain. This is going to be the first argument of the returning values. Then we'll have the data of the test partition, as we begin with x here with the data. Then we will have the training partition of the response variable. So here we will have ytrain, and finally we will have the test partition of the response variable, like this, right? So this method is going to return 4 values. This one is the data in the training partition. This is the data on the test partition, and this is the response variable on the train partition and the response variable on the testing partition. Very well. So now let's run this window. Very well. With this we have partitioned our dataset, and now in a new code window we can see the new shapes of each of these subsets of the training and the test, right? And we're going to compare with the previous ones that we had with the x and the y. So first of all, let's just type the x and the y shapes. So y, the x shape and also the y shape. We can print this. If we run, we can see that this data has this number of instances, the y the same. Okay, the only difference is that on the x variable we have all of the data, all of the columns, all of the information, and here we have only the response variable, right? So if we compare this with the training, the test, and for the data and the response variable, we can see, for instance, the train shape, right? And then we see the same for the test shape. Let's start with this too. So we can see that on the training partition we have this number of rows, 381, we have this number of instances, and on the testing partition we have this number, 888. The number of columns, as we can see, is the same in both as well as in the X. Here we only select the given rows for the partition, right? The columns are the same, and keep in mind that we're using a test size of 33%. That's why we have here a 67% of this value is going to be 381, and a 33% of this value here is going to be 888, right? If we check this with the y, it's going to be the same idea, shape, and the y test shape. The only difference is that the number of columns is going to be 1. If we rerun, we see the same thing, right? This same number of rows, because this is the same as the training partition, right? This is the training partition of the x, and this is the training partition of the y, so they have the same number of instances. And on the y we only have one single column, okay, for the response variable, and the same here on the test. We see we have the same number of instances as on the x test, but now since this is the response variable, we have only one single column. Good. With this we have the partition. We can change the name of this notebook to just be the partition of dataset. And with this, we end this lesson where we partition our dataset into the training partition and the test partition. Remember that you can download all of this code and all of this notebook on the downloadable documents of this lesson.